In this video, we will be talking about hypothesis testing for population parameter. We will look at some examples and basic concepts. Basically, hypothesis testing is a method of drawing conclusion about population parameter from sample. For example, if we have a sample of randomly selected adults in a town and 52% have college degrees, then what can you say about the population? So this involves hypothesis testing of proportion of adults with college degree. Based on this sample, can we say that half of the adults in town have college degree? Or can we say that more than half of the adults in town have college degree? If we look at the sample, 52% in sample have college degree, so it can be very tempting to say that more than 50% have college degree. But to generalize a sample proportion to population proportion involves rigorous statistical method which we call hypothesis testing. Next, we will define null and alternate hypothesis. We denote null hypothesis by H0 and alternate hypothesis by H1 or HA. The null hypothesis generally states the pre-assumed value and alternate hypothesis states the claim. Let's look at this example here. Researcher wants to test if average income of households in a town is 32,000. So the null hypothesis will be mean equals to 32,000. Basically, 32,000 is the pre-existing value or the value that the researcher wants to challenge. So we have this for null hypothesis. Now, the alternate hypothesis, HA, is the claim. The claim is that mean is not 32,000. The claim here is mean is not equal to 32,000. Here is another example. This one is talking about proportion. So here the pre-assumed or pre-existing value of proportion of high school graduate in the town is 0.82. Therefore, null hypothesis P equals to 0.82. And the alternate hypothesis is the researcher claim, which is that the proportion is not equal to 0.82. Again, here we need to identify null and alternate hypothesis. Whenever we say majority of both, we mean 50%, which is proportion of 0.5. So our null hypothesis is P equals to 0.5. And the alternate hypothesis will be the candidate's claim. She claims that she will have more than 50% of votes. So the alternate hypothesis is P greater than 0.5. Let's look at one more example. This one talks about average GPA. So the null hypothesis is mean equals to 2.61 and alternate hypothesis is the claim we want to test, which is mean less than 2.61. Based on the alternate hypothesis, we can classify testing into three types. They are lower-tailed test, upper-tailed test, and two-tailed test. So when we have lower-tailed test, significant values are at the left or at the left side. When we have upper-tailed test, significant values are on the right side or at the right tail. And when we have two-tailed test, significant values are at the both ends. So every time we do hypothesis testing, it is necessary to know that what type of test we are doing because it determines the nature of critical values and also how we calculate p-values. Like we saw in some examples, when deciding if a test is lower, upper, or two-tailed, we need to look for some keywords. For example, if claim has the phrase less than, then we will most possibly have lower-tailed test. If claim has phrase related to something like greater than, we will most possibly have upper-tailed test. Similarly, if the claim says something like different or not equal, then we have two-tailed test. Of course, you will see what I am talking about in the next videos in this series when I do application examples. Here we will talk about critical values. These are the values that separate the significant values with non-significant ones. These are the boundary values on Z or T distribution. They depend on the type of test, as we can see in the graph below. Note that the total area outside the critical value is the significance level alpha. For lower and upper tails, we have the area alpha just on one side, but for the two-tailed test, we divide alpha into two tails, so area on each side outside critical values will be alpha over 2. So if we look at this example here, this is a two-tailed test. So we have critical values on two sides with area alpha over 2 each. Let's put that in the graph here. So here our alpha is 0.05, and since this is alpha over 2, this becomes 0.05 over 2. So 0.05 divided by 2 is, let me write it down here, is 0.025. And same over here. So this area is also 0.025. So we need to find Z values. So this point here, this and this, such that area at tails is 0.025. To find that area, we can use a TI calculator, Z table, or Excel. Here, I will use TI calculator. For other method, please see my other videos. Now, let me pull up my calculator up on the screen, then hit second distribution, then we'll be using inverse norm function, then select that, then hit enter. Calculator takes area to the left. So now let's look at this point here. So if we look at this point here, then area to the left from this point is 0.025. So let's put that here, 0.025. Then our mu is 0 and our standard deviation is 1, then hit enter. So for critical values, now let me move my calculator here. Therefore, the critical values are negative 1.96 and 1.96. Next, this one is upper-tailed test, as we have greater than in alternate hypothesis. So we have area alpha on the right tail, and our alpha is 0.10. So we need to find Z value such that area to its right is 0.10. For that, let's use a TI calculator. Let me pull up my calculator up on the screen. Then go to second distribution. We'll be using inverse norm function here. So use this arrow key to go to number 3, then hit enter. Since we are trying to find this point here, calculator takes area to the left. So basically it would be 1 minus 0.10. Since we know this area over here, so this area to the left should be 1 minus 0.10. Our mu is 0 and sigma is 1. Then come down here, then hit enter. Therefore, the critical value is 1.28. This point here is 1.28. Now, let's look at this example here. So this is the lower tail test, and we are using T distribution. So we have area of 0.10, this area 0.10 at the lower tail, and we are supposed to find this point here. So to find this point here, we can use TI calculator. So for that, let me pull up my calculator up on the screen. Then go to second distribution and we'll be using inverse t function, which is number 4 here, then hit enter. So it takes area to the left, and if we are looking at this point here, from this point here, the area to the left is 0.10. So let's enter that 0.10. And it takes degrees of freedom, which is n minus 1. So in this case, our n is 19, which is given right here. So our degrees of freedom is 19 minus 1, which is 18. Then hit enter. Okay. So this gives us negative 1.331, and that's the critical value. So this point here is negative 1.331. So let's look at this example here. And again, this is a t-distribution, but it is two-tailed as alternate hypothesis says not equal to. So area at the two tails are alpha by 2 each. So these are alpha by 2 each. And we know our alpha is 0.02. So when we divide 0.02 by 2, we get 0.01. So this is equal to 0.01. So basically this area here is 0.01, and same over here, 0.01. So in this previous example, we used a TI calculator. So therefore, in this example, let's use a t-table. So for that, let me pull up my t-table on this screen. Since area at the tail is 0.01, look at the column of 0.01. So we'll be looking at this column here, 0.01. And degrees of freedom is n minus 1, which is 19 minus 1, which is 18. So look at the row of 18. So that means we'll be looking at this row of 18 and column of 0.01. So that means this is the number, which is 2.552. This number here, 2.552. We just looked at the row of 18 and column of 0.01. Therefore, the critical values are negative 2.552 and 2.552. Here we will talk about test statistics, significance level, and rejection region. Significance level, usually denoted by alpha, is the probability of rejecting the null hypothesis. Generally, alpha is 0.05 if it's not specified. Rejection region is also called the critical region. It is the range of t or z values where null hypothesis is rejected. So this is also the region outside the critical values, and the probability of rejection region is alpha. Here, let's look at this example. In this case, we are given null hypothesis mean equals to 14.2 and alternate hypothesis mean is less than 14.2. The distribution is the standard normal distribution Z, and significance level alpha equals to 0.05. Here we are looking at the Z value such that area at the lower tail is 0.05. And we are looking at the lower tail because the alternate hypothesis says less than. Now, to find the critical value, we can use Z-table, calculator, or Excel. Here, I am going to do it using a TI calculator. For details on finding critical values with other method, please look at my other videos. I will also post a link in the description. So to find the critical value, let me pull up my calculator up on the screen. Then hit second distribution. We'll be using inverse norm function, which is number 3, then hit enter. So calculator takes area to the left, and if we are looking at this point here, so the area to the left from this point is 0.05. So let's enter that 0.05. Our mean is 0 and sigma is 1, then hit enter, then hit enter. So here the critical value is negative 1.645. So let me write that down, negative 1.645. So this is this point here. Therefore, the rejection region is this, which we can write as z less than negative 1.645. Now let's look at this example. Here we have null and alternate hypothesis given like this. Note that this is two-tailed hypothesis since we have not equal sign in alternate hypothesis here. Now let's look at this example. Here we have null and alternate hypothesis given like this. Note that this is two-tailed hypothesis since we have not equal to sign in the alternate hypothesis. It also says we are using t-distribution with significance level alpha of 0.05 and sample size of 19. Now let's draw the rejection region in this graph. Since it is two-tailed, we have rejection region on both sides. So we divide into two parts. So this area here is alpha by 2 and our alpha is 0.05, so this area here is 0.05 divided by 2, 0.05 over 2, and that is equal to 0.025, and same thing with this side. So basically this side and this side are 0.025. Now to find this boundary value, we can use calculator or Excel or table. For now, I am just going to use calculator. So for that, let me pull up my calculator up on the screen. Now go to second distribution. We'll be using number 4, which is inverse t. Then hit enter. It takes area to the left. If we are looking at this point here, area to the left from this point here is 0.025. So let's put that there, 0.025. Then hit enter. Our degrees of freedom is n minus 1. Our n here is 19. So our degrees of freedom is 19 minus 1, which is 18. Then hit enter and enter. So this point here is negative 2.10 and this point here is 2.10. And if we look at this diagram here, so these are the rejection region. So therefore for rejection region we can also write as t less than negative 2.10 and also t greater than 2.10. Now let's look at this example. Here we have null and alternate hypothesis given like this. Note that this is upper tailed test since we have greater than sign in the alternate hypothesis. It also says we are using t-distribution with significance level alpha equals to 0.05 and sample size n equals to 19. Now let's draw the rejection region. So since it is upper tailed test, we know this area here is 0.05 and we are supposed to find this point here. And this will be our rejection region. So now to find this boundary value, we can use TI calculator, Excel, or table. For this one here, for this particular example here, I'll be using TI calculator to find the critical value. So for that, let me pull up my calculator up on the screen. Then go to second distribution. We'll be using number 4 where it says INVT. So that's what you need to select. Select that. Then this takes area to the left. So if we are looking at this point here, the area to the left of this point will be 1 minus 0.05. Our degrees of freedom is n minus 1 and here our n is 19. So 19 minus 1 is 18. So let's enter that, then hit enter. So our critical value here is 1.73. So let me put that down here, 1.73. So this value is this point here. So here the rejection region can be written as t greater than 1.73. Now let's define test statistic. It is a number calculated from sample statistics using an appropriate distribution such as z or t. So test statistic is used to decide whether to support or reject the null hypothesis, and it is obtained by using formula or technology. So here we will talk about test statistic in detail in my other videos in this series. Here we will look at p-value or observed significance. P-value, also called observed significance, is one of the ways to decide whether or not to reject null hypothesis. As shown in the graph below, it is the area outside test statistic. If test is a lower or upper, we simply have area at one tail, but if it is two-tailed, we find area at one of the tails and multiply by 2 to get p-value. So let's look at this example here. In this example, we have a lower-tailed test as alternate hypothesis has less than sign. Test statistic is given to be negative 2.31. So p-value is area to the right of negative 2.31, this area here, which means p probability of z less than negative 2.31. So to find this area, we can use a z-table, Excel, or TI calculator. Let me use a TI calculator here. So let me pull up my calculator up on the screen now. Do second distribution. We'll be using normal CDF, then hit enter. Then for lower value, enter some large negative number like negative 999, and our upper value here is negative 2.31. Then our mean is 0 and our sigma is 1, then hit enter and enter. So this gives us 0.0104, and that's our p-value. So basically this area here is 0.0104, and this is our p-value. Now let's look at this example. So this one is a two-tailed test, and test statistic z is negative 2.31. So we need to find area outside of negative 2.31, this area, and multiply that by 2 to get p-value. In the previous example, we used a TI calculator. So for this one, let's use a z-table now. So for that, let me pull up my z-table up on the screen. Now look up negative 2.31 on the table. So for that, look at the row of negative 2.3, this one, and column of 0.01. So which is this one here? This number here is row of negative 2.3 and column of 0.01. So that gives us 0.0104. So basically this area is 0.0104, and similarly this area is also 0.0104. So p-value is 2 times of 0.0104, which gives us 0.0208. Therefore, p-value equals to 0.0208. Now let's talk about the conclusion of hypothesis testing. The final step of a hypothesis test is to make a decision about null hypothesis. For that, we can use p-value or test statistic. We reject null hypothesis if test statistic is outside the critical values, and also we reject null hypothesis if p-value is less than given alpha. So now let's look at this example here. In this example, we have test statistic z equals to negative 2.05. To draw a conclusion, we can find p-value or critical value. So let's try both for this problem. First, let's find p-value. P-value is simply the area below negative 2.05. For this, let's look up negative 2.05 on Z table. So let me pull up my table up on the screen. Now we'll be looking at negative 2.05. So basically we'll be looking at row of negative 2.0 and column of 0.05. So that gives us 0.0202, this value here, 0.0202. So therefore, let me write that down here. So therefore, our p-value is 0.0202. So this is our p-value, and our alpha is 0.05, 0.05. Since p-value is less than alpha, we reject our null hypothesis. Therefore, reject null hypothesis. Now, let's do this using critical value. To find critical value using a z-table, let me pull up my table up on the screen. Now, find number closest to 0.05 among these tiny 4 decimal place numbers. So, closest I can find here are this one, 0.0505 and 0.0495, this one. So the closest number that I can find here is 0.0505 and 0.0495. So the z values for these are negative 1.64 and negative 1.65. We take the value between them, which is negative 1.645. Therefore, critical value is, let me write that down. So let me write that down over here. So therefore, critical value is negative 1.645. And test statistics is negative 2.05. So now let me draw a diagram here. Let me actually use a different color pen. If our critical value, negative 1.645 is here, so this one is negative 1.645, then our test statistic, negative 2.05, is somewhere here, negative 2.05. From here, we can see that test statistic is outside the critical value. So therefore, we reject our null hypothesis. Next, let's look at this example here. This is a two-tailed test with t-distribution. First, let's do this using method of critical value. To find critical value, we'll use table. So for that, let me pull up my table up on the screen. Now, look at the column of alpha by 2. Since it is a two-tailed test, so look at the column of 0.05 by 2, which is 0.025. So this column. And look at the row of degrees of freedom, which is n minus 1, which is 16 here. So 16 here, basically we'll be looking at the row of 16 and column of 0.025, this column here. So that gives us 2.120, this number here. So therefore, critical values are negative 2.120 and 2.120. And we know our test statistic is test statistic t is negative 1.92. Now let me draw a diagram so that we can see our test statistic and critical values on this graph. So let's say our critical values is this. So this point here is negative 2.120 and this point is 2.120. That means our test statistic, which is negative 1.92, is here. So this point here, let me mark it with different colors. So this is negative 1.92. So from this diagram here, we can clearly see that test statistic is inside the critical values. Therefore, we do not reject our null hypothesis. So now let me show you how to make this decision using p-value. So to get p-value with t-distribution, we must use technology. Let's use TI-84. Now let's use TI-84. So for that, let me pull up my calculator up on the screen. Now go to second distribution. Then we'll be using TCDF, which is number 6 here. TCDF, then hit enter. So here we want to find area below of negative 1.92. So enter some large negative number like negative 999 for lower value, and for upper value we'll be using negative 1.92, negative 1.92, and our degrees of freedom is 16. And hit enter and hit enter. So that gives us this number here. Therefore, p-value is 2 times of 0.0364, that is 0.0729. So now we have p-value which is 0.0729, and we know our alpha is 0.05. Since p-value is greater than alpha, do not reject our null hypothesis. So do not reject null. Next, let's look at this example. Here, alpha is 0.10 and p-value is 0.04. So we can compare them right away and we can see that p-value is less than alpha. So we reject our null hypothesis. So reject null hypothesis. Thank you for watching. We hope this video was helpful. Please like and subscribe our channel. We will be bringing more and more videos on variety of topics.